So recently I picked up this Canon EFS 1855 zoom lens for quite cheap because the autofocus function was broken. And we can hear that the focus motor in the lens still seems to be working, but something seems to not be going right, as the camera does not focus and instead makes a weird whirring sound. And so maybe we can take a look inside of the lens and see if we can't fix the problem. So if we set the camera to autofocus mode, we can see the zoom wheel wiggling free, and in manual focus it seems to make weird clicking noises as we turn the focus ring. So clearly something mechanical inside of the focus assembly seems to be going wrong. Getting into the lens is quite easy. There's 4 screws on the rear that we can take off using a PH000 screwdriver. There's also 2 more screws on the side of the pin connector that electronically connects the lens to the camera. These are quite small screws, and so it's good to have the window closed while doing this, because even a mild gust of wind can blow these screws off of your desk, and they're not easy to find on the floor, especially not on carpet, like in my case. With the screws removed, we can take off the back plate, but we need to be careful because it's still connected to the lens body with a small ribbon cable. The sensors in the back plate are inertial sensors related to the image stabilization, and so it's quite easy to damage this ribbon cable. Next, we will remove the PCB from the lens, and it is connected via these 5 ribbon cables to the lens body. And so luckily these ribbon cables have a hole in them, so that we can slip something sharp like just a set of tweezers into them and give the ribbon cables a gentle tug to remove them from their connectors without damaging them. These ribbon cables are sadly quite fragile, so we need to be a bit careful. The PCB itself is not screwed down, but simply sits on a few plastic pins with these rubber grommets, so we can just give it a mild tug and it comes off. Under the metal plate is the actual autofocus assembly, and we'll leave the assembly inside of the lens and simply remove the metal plate so we can take a look at the gear train. The second screw here is hidden under these ribbon cables, and we'll need to move them out of the way to get access to the screw. It's good to have a set of tweezers handy to remove these small things without dropping them inside of the lens body, which would be quite bad. The back plate is kind of entangled with the ribbon cables, and it needs some mild convincing to come off of the lens. With the metal plate removed, we can finally see the gear train for the autofocus. There's a tiny spring that we'll likely lose if we're not careful, so I'm removing this one here. And so now we'll have a look at these gears. These are made out of plastic and they're quite fragile. And so I'm going to remove these one by one and take a look at them and see if any of them are damaged, because that could explain our focusing problems. And indeed, the second gear we look at is hardly a gear anymore. More than half of the teeth are stripped off of it. And so that gear no longer works properly. It will start spinning freely when it hits that part of the gear without the teeth. And that's probably the sound we heard when the camera tried to focus. This probably happened when the previous owner of this lens had it in autofocus mode, but tried to turn the focus ring, thinking it was in manual focus. And so the gears won't move, but the force of turning the focus ring has to go somewhere. And so in this case, it stripped the gear. Luckily, the replacement gears can be had from China for around $3. And so I got these in the mail. And we can see that one of these gears does actually match the damaged gear, except it has all of its teeth. And so we can use this as the replacement part. Now it's just a matter of reassembling all of the gears. In this case, only one was damaged and needed to be replaced. All the other ones can be left as originals. Reinserting the gears can be a bit tricky because we want them to mesh as we put them in, so the gear train actually works. But with a bit of patience and a fine set of tweezers, this is not too difficult. Here I'm just giving the biggest gear a mild push to see if all of the other gears turn and to see if everything is meshed together. Not to forget putting back the little spring for the gear that switches between auto and manual focus. And then we can put back the metal plate that keeps it all together. Putting the screw in is a bit inconvenient under these ribbon cables, but with a bit of convincing and some tweezers, it's luckily not too difficult. Now we put PCB back into the lens, and so we need to make sure we're not squishing any of the ribbon cables under the circuit board. And of course, also need to make sure the board is rotated the right way around so it aligns with the plastic pins that keep it in place. Once it's aligned, we just give it a slight push and it pops into place. Now we carefully reinsert the ribbon cables into their connectors. And so here I'm again using the holes in the ribbon cables to give them the force to slide them back into the connector. And I'm using the other leg of the tweezers to carefully guide the ribbon cables back into their connectors. And so that seems to make this quite easy. Now comes probably the most challenging part, which is putting the backplate back on while also hooking up the ribbon connector to the main board. This is a very small connector on quite a finicky ribbon cable, but after a few attempts I managed to put it into its socket and give it a mild push for it to slide back in securely. Then we just need to align the hole in the backplate with the camera connector, and we're almost done. With everything back in place, all we need to do is put the screws back into the lens. Of course, not to forget the two tiny screws that holds the connector in place, assuming we haven't lost them to a small gust of wind. And with that, the repair is complete. If we turn the focus wheel now in manual focus, you can hear that it turns smoothly, there's no clicking, and the zoom function still works without any mechanical issues. So now comes the moment of truth, putting it back onto the camera, setting it to autofocus, and hopefully when we turn on the camera, the lens will now focus. Testing out a few different distances, the lens does actually focus now. The camera gives us a nice beep when it's in focus, and the repair is complete.